Okay, intro to stats. We're going to pick up where we left off. So we were working with binomial experiments in lesson 4.2. And what we're looking at today would be the probability of a binomial experiment. We're going to come back to these slides on mean variance and standard deviation again towards the end of the lesson. So I'm going to skip over them for now. Okay. We have a probability formula for binomial experiments. This one right here that I'm highlighting is the one you need to write in your notebook. The other one just gives you the formula for your combination notation. All right, N stands for the number of trials, P is probability of success, Q is the probability of failure, and X is the number of successes. In our first example, you have microfracture knee surgery. It has a 75% chance of success on patients with degenerative knees. Surgery is performed on 3 patients. Find the probability of the surgery being successful on exactly 2 patients. So back in chapter 3, if we would have had this problem, you might have written out a tree diagram. And by doing the first surgery and then your second and third, you have all of these outcomes right here. Then what they did was they found the combinations where they had exactly 2 successes. And in order to get that particular probability, you would multiply the 3 out of 4 for success, 3 out of 4 for success, and 1 out of 4 for the failure. So that's 9 over 64. Remember, it's 75% chance of success. So each S is 75%, each F is 25%. They have that showing up 3 times, so they multiplied it by 3. That's a lot of work. If we do the formula instead, we're going to shorten the amount of work that we have to do. And so here we go. This is the formula for that situation, or this is how we would use the formula for that situation. They have all of these things from the word problem. So we had 3 trials. Success rate was 75%. So your P is 25%, and we're looking for exactly 2 successes. So remember the formula was NCX, P to the X, and then Q to the N minus X. So that's what they've done here. They plugged in everything they had from up here. And you wouldn't be doing this part in particular. You're just going to take this right here that I'm highlighting, and you're going to put that right into your calculator. And we're going to get the same answer that you saw with the tree diagram. Okay. Here's another one. A survey indicates that 41% of women in the U.S. consider reading their favorite leisure time activity. You randomly select 4 U.S. women and ask them if reading is their favorite leisure time activity. Find the probability that at least 2 of them said yes. Now what you have to watch for, once you've got your N, P, and Q lined out, at least 2 means 2 or more. So you have 4 women that you selected. We want to know if 2 or more like reading as their favorite leisure time activity. So we're going to add P of 2, P of 3, and P of 4 together. And so they've done that for 2, 3, and 4. So they're using the formula 3 times. Then they're adding those together. This is the final response. Okay. We're going to try to do some on our own here. A card is selected at random from a standard deck and replaced. The experiment is repeated a total of 5 times. The probability of find the probability of selecting exactly 3 clubs. So let's start with that one. Okay, the first thing we're going to do is set up our N. Let's see, N is 5 because we're pulling out 5 cards. We're going to do this experiment 5 times. P, we're looking for a club that's 1/4 of your deck of cards. It's 13 cards out of 52, which is 1/4. Your Q then is going to be 3/4. Now you can also use decimals. All right. And we're going to find the probability of getting exactly 3. So again, here is your formula: n cx p to the x q to the n minus x. All right, so we have 5 c, and we want 3 of them, 3 clubs. And then it's going to be 0.25 to the x and 0.75 to the second. All right, we put that in our calculator, and we're going to round that to 3 places. So that's almost a 9% chance. Okay, this one is in your textbook. It's number 18 on page 217. And I think what I'm going to do is pause this video here and then do another video just with this problem, because it's kind of a long problem and I don't want to run out of time. I can upload my YouTube videos when they're under 15 minutes in length. So I'm going to stop and then start again.